Hi, everyone. Today we're going to be talking about Kubernetes and my strong opinions about how the code is structured. Oh, sorry. Where's my boundary here? Okay, cool. Yeah, we're also going to look at some mountains and stuff because that's what we do. All right, so this is me. I'm a contributor, maintainer, / I think I'm in an owner's file, or at least I was until last night. For a lot of things in Kubernetes, SIG AWS, SIG cluster lifecycle. I helped out with COPS a lot. I've written a lot of infrastructure tools. I've just been hanging out in Kubernetes for like the past 2 years. I wrote this book last year. I'm working on another one this year. And then just in general, I just write a lot of code in and around Kubernetes. And I'm also super gay. Okay, so once upon a time in 2014, Kubernetes, whoa, this is going too fast, let's go back. Once upon a time in 2014, Kubernetes was open sourced, and you actually can go to the GitHub Git logs and look at the first commit from one of my good friends / boss / colleague named Joe. And we're going to talk a little bit about what Kubernetes was like when it was first open source. So to quote Joe, we took Brendan's prototype, Brendan Burns, one of the other original founders who worked at Google at the time, which was written in Java. We rewrote it in Go, and we built just enough to get across the core ideas. So this is a big, this sort of sets the stage for the software that we're looking at. They moved it over to Go, but originally the entire design of the software was originally written in Java, which is obviously an object-oriented language. So we're going to be learning a lot today about how Kubernetes adopted some of these exciting and interesting object-oriented principles in Go. Okay, so to get started, we're going to talk about these things all day today called antipatterns. And I actually went and looked this up and pulled the definition off Wikipedia, and I kind of bolded the two things that I really think define what an antipattern is for me, other than just a buzzword that you can say when you don't like somebody's idea. Like, that seems like an antipattern. We shouldn't do that. No, it actually, it means something. And it's actually pretty exciting when it means, because there's usually a common theme of how you get here. But I'm just going to read really quick. A commonly used process, structure, or pattern of action that, despite initially appearing to be more appropriate of an effective response to a problem, has more bad or more negative consequences than good ones. In other words, it looks like it solves the problem, but it actually creates more negative consequences along the way. And this is the second bit of criteria here. In order for it to be a true anti-pattern, another solution has to exist. In other words, there has to be some other path that already exists without us spending any engineering hours to go and actually undo this thing that we thought was going to do good that ended up doing bad for us along the way. So that's what an anti-pattern is. Okay, so we're going to get started, and we're going to talk about these things called objects in Kubernetes. Who here knows what a Kubernetes object is? Really well, you've actually written a new one from... Okay, everybody just put their hand down. Okay. Okay, so yeah, most people think of a Kubernetes object, they think of some YAML or something like that. But we're going to go a little bit deeper and actually look at what makes up a Kubernetes object in Go and talk about this word object in general. So we're going to pull some metrics. So if you go to kubernetes.io, it's our documentation site. I actually went into GitHub and did a search, and there's 300 references to the word object, capital or lowercase, in our documentation website. Furthermore, there's over 3,000 references to the word object in the Kubernetes code base. The way Kubernetes is set up is there's this one sort of magical repo here that's Kubernetes, or sometimes referred to as core, or sometimes referred to as KK or K/K. And that's sort of the main bits and pieces of Kubernetes. And there's about 300 other repositories that also do important things in Kubernetes as well. But we have the word object in there over 3,000 times. Okay, who wants to tell me if objects exist in Go? No, you're wrong. They do exist in Go. If you go and you look into Go and you search for Go, and actually, if you would have asked me this about 4 hours ago when I was working on my talk, I would have said the same thing. But this is actually really interesting. I learned today, so I'm going to share. There is a really important object in Go. If you go look in Golang/Go, I found this one I wanted to point out. It's actually an interface. It's called the object interface. It's in the Go standard library, and everything in Go, it says an object describes a named language entity such as a package, constant type, variable, or function. So literally, this is the thing that makes up the things that we write as software engineers. So there are objects in Go, but they have nothing to do with an object-oriented principle, and certainly nothing to do with objects in Kubernetes. Okay, so here's what a Kubernetes object is. Okay, so first off, everybody calm down. It's literally just a struct in code, but for some reason we've been calling it objects for the past 5 years. So that's what all the documentation says, and that's what's littered throughout our code base. These things are excited because they're versioned API objects, and that's kind of a fancy way of saying we wrote some structs and we put all the ones from January in a directory and we put all the ones from February in a different directory. They probably have some similarities between them, and we just say don't use the ones from January if they don't work for you. And it's not quite that simple, but we do version our objects over time, and they do grow and they do change. And we are able to create some sort of guarantee with that in Kubernetes. And then more importantly, we have humans who will argue about the shape of these objects very intimately on the Kubernetes mailing list if you ever want to join and learn about the API objects we're defining. But ultimately, they have two things. They have fields, just like a struct. It's any type you want to create, any of the built-in types. And they have associated logic with it. They have methods, just like a struct. Furthermore, they can be defined as YAML. We've all seen Kubernetes YAML before. But because it's a struct, it can actually be defined as JSON or any encoding language for that matter. If you actually use the kubectl command line tool, you can do -o JSON, and you actually do everything in JSON. You definitely don't have to use YAML in Kubernetes. And last but not least, it uses a lot of composition and embedding. And this is the first hint into object-oriented principles in Go. Who here knows about composition and embedding in Go? Okay, so about half of you. But basically, it allows us to define common objects and common fields and then share those throughout other objects along the way. And we're going to look at a very simple object in Kubernetes, and we're going to go a little bit more into composition and embedding in a moment. So the simple object here that we have defined is a pod. It has a kind, more on that later, an API version, which we just talked about. And then it has some meta information, this thing called a spec, and this thing called a status. But ultimately, we think of it as YAML, but in Go, it's going to be represented as a struct with some nested structs inside of it. Next slide. I dropped my clicker. Okay, so if we look at a Kubernetes object a little bit more in detail here, we're going to look at what these nested structs and these nested things are. And these are embedded into the broader object. So in the middle, the larger square, this would be some Kubernetes object. This could be a pod. This could be a deployment. This could be something you and your team wrote that is important to you and your organization. And the first thing in the top left corner, we have a meta v1 object meta. So we've went out of our way, and we defined this thing in Kubernetes called object meta. And object meta is embedded to every Kubernetes object out there. It defines things like a name, the namespace that the object is running in, labels and annotations, and it's actually about 400 or 500 lines of Go long, commented very well. And every object has that, and we embed that in there, and all of the logic comes along with it after we embed that into a Kubernetes object. The next one is we have a type meta. So the type meta is relatively simple compared to object meta. It has kind and API version, and all kind is basically the name of another one of these magical Kubernetes objects. And you can go ahead and define the kind. Last but not least, we have a spec. So this is whatever is important to whatever we're defining. In the case of a pod, it might have something like a container or a port that it's listening on. In the case of you and your team, it's whatever you care about in your software. And last but not least, we have a status. This is the unique fields that are important to your thing. In other words, what is the state of this thing right now? Is it pending? Is it exited? Is it happy? Is it healthy? What's going on? And all of those can be defined in Go in API machinery package APIs meta v1 types.go. Okay, so how do we use these objects? Because they're typed, we can version the fields over the time, which I mentioned earlier, meaning that as we're changing our fields, we can put in those backwards compatibility guarantees. Furthermore, we can graduate them into different areas of the API. So everything in Kubernetes starts off in alpha, and we can move that into beta, and we can ultimately retire that if needed, and we can sort of advertise that to the community as we manage all of these structs we're defining in Go. We can define arbitrary fields, and again, we can literally just use them as structs in our code. If you've ever vendored Kubernetes client Go before, if you want to create a pod, you actually initialize a pod struct and then pass it to your client, and that's how you create a pod. Okay, so what's the anti-pattern here? So there's a lot of over-engineering in my mind going on here. We're basically re-implementing a a typing system, right? We've gone through and we said we're going to create all these new types. We call them pods, and a type in Kubernetes has all this wonderful meta information about it with all this built-in logic. But maybe the Go type system natively also would have given us a lot of those features out of the box if we could have just taken advantage of it. So we've created this hybrid system of we use Go in the Go standard library to do things like type assertions on our structs, but we have our own built-in kind assertions, which effectively do the same thing that are only relevant to Kubernetes. So again, Go already solved this, and the type system is customizable using custom types. So this is our first step towards object-oriented coding in Go, as these objects start to play with ideas like polymorphism, inheritance, encapsulation. All right, let's talk factories. I know we all love a good factory. That was a joke. Come on, I'm killing it up here. OK. We're going to talk about these things called shared informers. Who knows what shared informers are in Kubernetes? 1, 2, 3, 4, 5 hands? OK, 5 hands went up. A shared informer is this really important part of a controller. And all a shared informer does is it just defines things like all of the different API groups your controller might be interested in interacting with. So these are things like core. Core has things like pods inside of it, storage and network, et cetera. And these are all of the different objects in Kubernetes. A shared informer is just a grouping of these, and we have a shared informer factory that we can use to go and initialize all of these wonderful Kubernetes objects behind the scenes. One of the problems I personally have with this is we're kind of hidden from what's actually going on here. So this hidden meaning for creating a new shared informer factory is actually fairly vague when you look at it. Furthermore, it's an interface composed of interfaces. So while that's flexible, it's actually quite confusing, and it's really hard if you ever try to actually go through and look up what you're doing. You need to do about 3 or 4 type assertions to get down to the actual literal object you're interacting with. So these shared informer factories are convenient, but they come at a cost, and that cost is some vagueness and some complexity. So if we actually go and look at the client Go shared informers factory.go code, we can see if you call good old new shared informer factory, you pass in a Kubernetes client. Of course, that's an interface. And you give it a duration. And then that calls new shared informer factory with options and just passes off some of the values that came into it. So this is a very common pattern. If you've ever looked at Java before, like Java loves to do this kind of stuff. Like you have a function that just simply calls another function and doesn't really do anything else. And then below, we have this other one that is new filtered shared informer factory. And that does the same thing, except this time it passes in some sort of arbitrary filter so that the outcoming shared informer is going to look a little bit differently than it would in the example above. So we're generating a lot of code here. A couple of different packages will vendor this, and then you can go in and you can actually see what's going on behind the scenes if you scroll down in the file, and all you'll see is that both of these functions are effectively newing a struct and setting a few defaults and returning a new struct. So that's all we're doing with this shared informer factory. So we could have just done all this literally. We could have just built literal structs with the methods that we need and assembled them as needed. So if you look at the diagram on the right, here we have a controller that would use something like a shared informer. And you can see in this example, we might need storage and core, or we might need, in another controller example, network to come along and join the party as well. Defining this literally in Go is one of the huge important features of Go, is that we've gone out of our way to make it a point to do things, to keep things like generics out of our code base, so that we do have to go and define things literally. We make you go define literal errors. We make you go and define literal structs, excuse me. And that's one of the big features of Go. So anyway, it could initialize informers as we needed them instead of all of them, and we wouldn't be going through and abstracting ourselves away from the code, so it would be simpler and easier to understand along the way. Okay, so too many assumptions. That's what's going on here. We made too many assumptions about what the user wanted or what the developer wanted. And to me, that's like the big red flag, right? Like when you go and you create a factory and that factory does 90 things that it just assumes you want to set these defaults, that's probably a sign that you're going out of your way to make something a little too easy for someone, that you're actually masking what's really going on there. So granted, it does guarantee certain values are populated because you're forced to pass them into the function, but there's other ways that we can do this. A really great example of this is if you've ever used Steve's Cobra command library in Go. That forces you to define a default, and that default is going to go and get populated wherever you want it to go populated. So you can structure your code in such a way that you can guarantee that these fields can be populated without having to go through and create all of these noisy factories. And again, making too many assumptions is a sign of a wrong or incorrect abstraction. Let's talk about the Kubernetes monorepo, which always makes me really happy because Kubernetes is supposed to help you not do this, but Kubernetes is totally a monolithic repository. Okay, so there's about 20 different main functions in github.com/Kubernetes/Kubernetes. These are all independent executables, and all they do is they have a main function that usually calls about 3 or 4 other functions that don't really do anything, and then one of those 3 or 4 other functions start to call things out of the PKG directory. This is exciting because we start to run into situations where we get cyclical imports in our code, especially if we start trying to import packages from PKG into other packages and then run them in our CMD directory outside of that. Furthermore, these are all built using the same build system, and there's a lot of them that are tightly coupled together. For instance, if you want to go build the Kubernetes API server, you're going to have to build the rest of the control plane along the way to even make a change and test and see if your code is working. So building this monolithic build system actually makes it hard to develop on one piece of the Kubernetes code base. Furthermore, all of this is in one repository, which is a pain in the ass for humans. Right now we have 2,000 issues, which this is actually low for us. So if this was like a year and a half ago, if we would have been giving this talk, I was at about 6,000 issues. So we did a lot of good work cleaning them up, but still the point that we have 20 plus projects working out of the same repository means GitHub is insane. So yeah, we have a lot of different groups managing in the same repo. Okay, so yeah, like I said, this is actually better than previous versions of Kubernetes. And ultimately, this only builds our good old static binaries that we love from Go so much. This actually doesn't get anything into a container, which again is the whole point of Kubernetes. A lot of this build system is tightly coupled, example, the control plane. And we are starting to refactor this. We've been saying that for about a year, and we're slowly getting there. And we're going to talk more about our first approach here in a second. Okay, so refactoring the Kubernetes monorepo. We've been working on it. So here's what we did. So we had a handful of arbitraries in like around Go version or Kubernetes version 1.10, and those were all in the root directory of the repository. We moved those down into this lovely subdirectory called staging over the past couple of versions. Each of those now point to github.com/Kubernetes/ whatever the name of the original package was. And those are actually defined in 2 places. In other words, if you want to define the API package, you could go to github.com/Kubernetes/API, or you could go to the Kubernetes core repo /staging/API, and we actually have 2 copies of the same code. The reason that we're doing this is so that we can start to plumb our code through the staging directory out to these other repositories, but nobody's actually going and maintaining these other repositories. They're basically just like a blind dump that we hope is accurate. Okay, so what's the anti-patterns here? So it's a monorepo. So it seems convenient. When we started out, it was like we're all working in one place. We're all building code that we want to use. It's actually easier for us to compile this because we don't have to deal with any of the vendoring concerns because everybody loves vendoring in Go. And it actually turned out to be way more complex as the project grew over time and as we got more and more contributors to the project. The new library features can conflict. If somebody needs to make a change because they have a bug in a version of a library and somebody else also wants to make a change, it's going to be really hard to try to convince someone to let you make a change to the function definition in these shared libraries that everybody is using. Furthermore, it's tightly coupled applications, so the applications really can't run anywhere else, and you notice that we start to build the same thing over and over and over again because we're using all of the same libraries in the same repository. And last but not least, it's a mental overhead for developers. Like, there's a lot in Kubernetes. It took me about 2 years to get where I am today, and I've been looking at that code base like once a day. And it changes every day, so it's a lot to learn, and if you just want to learn one small thing, you basically have to learn the entire ecosystem first and then learn how to cherry pick your thing out of there. Furthermore, it sort of increases this elite mentality that you have to be this Kubernetes expert and know all of these millions and millions of things in order to contribute, when in fact you really don't. You just need to change like an int32 to an int64, and hey, we're having a party. Okay, cool. So the Antipatterns here. There's two sources of truth. Do I trust github.com Kubernetes staging, or do I trust github.com/Kubernetes/whatever? So which one do we vendor, and which one should we vendor? And there are examples of doing both of these, and the answer is it's kind of up to you, and you can kind of do both. So the time of the sync is a concern. We cut a release at t = 0. At t = 1 is the new ported repository updated. Probably not. So there's always going to be some delta between the two. So when do we sync the code? And last but not least, vendoring is a problem. Which one do I want to vendor? Okay, cool. So let's talk the core repo or the main repo, Kubernetes. So inside of Kubernetes, we have everybody's favorite subdirectory /pkg, which we all know is at one point was prescribed as a good idea, but since has been pulled back and said, hey, this probably isn't the best idea. And we have some other solutions we're going to offer in a second. Furthermore, the multiple mains can lead to cyclical package dependencies. I think I mentioned that already. And this breaks the standard library suggestion. So this convention comes from the original Go spec, but has since been deprecated. The Kubernetes vendor directory. So the way that vendoring works in Kubernetes is all of the executables that are built out of the Kubernetes GitHub repo all usually use the same vendoring directory. So if two projects want to use two different versions of a JSON encoder, you're going to have a bad time. Furthermore, we get into daemon vendoring, which is this problem of almost like cyclical vendoring, and now I'm getting off in the weeds with solving vendoring in Go. But basically, it's a pain in Kubernetes, and we see it even more so as the project has grown over time. One of the solutions we tried that didn't work out super well, but it was better, was we started symlinking dependencies during the build so that you could arbitrarily define, I want to use JSON package X for this executable, but I want to use JSON package N for this executable. And then the build system would go and do the magic symlinking behind the scenes to give you whatever package you need, which, of course, that sounds like a lot of fun. The CMD directory. So usually, on average, there's about 7 hops from the actual main function to where the program actually starts and starts going into business logic and actually taking action and doing something. Everything else is sort of a formality to go through how we build Kubernetes. So that's something that's really annoying for new developers as well, is even just to find where the code starts, you have to go through and dig about 7 hops in. And also, it's all the main functions for the project, which that's kind of nice because I can at least go and find all the main functions, but it doesn't actually define any of the command line flags that any of those main functions accept. So if you want to go try to figure out how to add a flag to a program, you're going to have to start here, go about 7 hops in, and then start looking at how all the flags are built in Kubernetes. So the anti-pattern here would be refactoring, or the lack thereof, rather. So we moved all these applications into the mains repositories with their own vendor. It's something that we could have done along the way, and we're starting to do it now, but again, we're getting into some trouble. We could have moved the libraries into other repositories as well. So not only just the applications, but also the libraries. So that everything that everyone is using now has its own version, and then everything that you're building that uses one of those libraries would also have its own version. And last but not least, we could totally get rid of the pkg directory and replace that with the /internal directory, which we all know in Go only allows you to vendor upwards, which could allow us to make some really powerful vendoring guarantees as we start enforcing how we want people to build and use the Kubernetes libraries. Okay, so there's a handful of other technical concerns with Kubernetes. I'm just going to give people a moment because this is like therapy for half of you. Okay. But the one thing we actually do is we actually do docs really well. So again, and this is one of my favorite things to tell Gophers, there's actually in the Go standard library documentation on how to write Go docs. Kubernetes actually follows that really, really, really well. So if you go and you look in the Kubernetes documentation, you're actually going to see that the first word is the name of the entity, or as we learned earlier, object. It's shared by all the top-level objects, the proper way to use it inline, and then it tells you a way or how to use whatever you're defining below. And then we have some fancy protobuf tags at the end with an example as well. So hats off to the Kubernetes authors for writing good Go docs. So Kubernetes is still impressive, despite the fact that we've got into a little bit of trouble along the way. It's widely adopted as the new cloud-native kernel. We have the main 3 cloud providers have all come and said, yes, we want to adopt these APIs. We have over 2,000 contributors in the top-level repository alone, with 476 releases, 100-plus repositories in the Kubernetes GitHub org, 30 SIGs, or special interest group, each managing code, each of those with n number of engineers working working for X companies. And we do all that, and we still are able to cut a build every 3 months, and that's pretty exciting. So in conclusion, we invented a typed object-oriented system with Go. It was actually pretty cool. It's how we get things like controllers and CRDs and Etsy, but it might be a little bit much. We use a lot of factories. Hey, nobody's perfect, but at least they work. We might be able to use a new struct instead. We have a giant repository. This is ironic because we use Kubernetes to build microservices, and this giant repo causes a lot of problems for engineers and people trying to get started in the Kubernetes code base. There's multiple copies of the source code, which that is a source of truth problem, and that makes it even harder for us to vendor. Furthermore, it introduces complexity. We can move package to internal, and that would start enforcing vendoring guarantees as we start refactoring our code. And furthermore, /vendoring is huge right now, and we would be able to slim that down a little bit. Last but not least, CMD is confusing. So we're still pretty damn good for what we're doing, but we have a long way to go. Thanks. Question?
One question.
No.
Oh, damn.
Yeah, in the back.
Any farther?
I can't hear you at all. Can you hear him?
We cannot hear anything, so either get someone to shout louder, or you can ask it later. Okay, we're out of time anyway, so you can come down and you get an answer. Thank you very much.